Good. All right, so we're going to build our circuit. We're building a series circuit. We're going to use one light bulb to begin with, 3 cells in our circuit, right? The first thing that I'm going to do is build the circuit, and then I'm going to attach the meters. Okay, so I'm going to build the circuit by connecting the one side of the cells, or the battery that we have, to the other side of the battery. Make sense? All right. So there I have my series circuit, and it's currently working. I'm now going to add in my voltmeter and my ammeter. Remember, an ammeter gets placed in the circuit in series. That means that I have to break the circuit or disconnect the circuit to add in the ammeter. So I've disconnected the circuit, and I attach the one side to the ammeter and the other side to the ammeter. My rule is that I always use the biggest scale on the meter first. So if you have a scale that says millimeters or centimeters or meters, the rule is you will also always start with meters first and then work your way down for the safety of the thing that's measuring. In this instance, we are talking about amperes because that is what your ammeter measures. It measures the current in the circuit. I'm going to be using one of 3 scales. Either I'm going to be using 5 amperes, 500 milliamperes, or 50 milliamperes. 5 amperes is the big scale, then 500 milliamperes is the next one, and the smallest scale we have in this is 50 milliamperes. All right, so now I'm going to connect it into that, and I'm going to complete the circuit. I get a teeny tiny reading, okay? Which means I can use a smaller scale, because if I use a smaller scale, my reading will get bigger. Sorry, Kim, can I ask you to just check whether we're getting the reading on here? Can you see the reading on there? All right. So now I'm going to take the next reading, and I actually quite like this 500 one, because it gives me a nice settled reading, and just the reading that you're going to write down, the first reading is going to be, I'm reading the top line because I'm plugged in from 0 to 500, and I've got 3 lines on the actual meter reading. It's got a 0 to 500, a 0 to 50, and a 0 to 5. I'm going to use the line that's got 0 to 500 because that's what I'm plugged into. Yes? And so I end up with 150. Sorry, I'm lying to you. 140 as my reading. What is this measured in? No. Milliamperes. So I have 150 first reading, 150 milliamperes. 140 milliamperes, correct. For the potential difference reading, the voltage reading, voltmeters are always connected in parallel. That means across a component. What that also means is that I don't have to break the circuit, I can just add the voltmeter on. Are we okay with that? Alright, so this point here and this point here. And I get a nice reading here. I'm plugged in from 0 to 3. And I am 1 short of 1.8. Okay. So, I have 1.2 and 1.8. Okay. Those are the readings that I have. I am 1 short of 1.8. Okay? The question is, between 1.2 and 1.8, I have 10 divisions. If I have 10 divisions, how much does each part represent? Between 1.2 and 1.8, I've got 0.6. Do you agree? But in 0.6, there are 10 divisions. Which means that each division is worth 0.06. Do you agree? Are you with me? Which means that if I'm 1 away from 1.8, I've got some options. I can say 1.2 plus 9 times 0.06, and I'll get my answer. because it's 1.2 plus all the bits over there, 9 of them. Yes? Or I could say 1.8 minus 0.06. It's entirely up to you. But what does this give me? Should be 0.74. Alright. The brains. So my next reading is 0.74 volts. Yes. Alright. Sorry, 1.74 volts. Thanks, Jim. 1.74 volts. That's reading number 2, 1.74 volts. But it's not reading number 2, it's the first set. The second part of the first set of readings. Yes? What's wrong? All right. What's yes? I don't know. You get to choose. So if you want your table in milliamperes, that's fine. If you want your table in amperes, that's also fine. If you want it in amperes, you will have to convert. If you use it in milliamperes, then you can use the readings that we use straight away. Did that make sense? You choose. Okay. By the way, what does milliamperes represent? Milliamperes represents 1,000th of an ampere, which means it's an ampere divided by 1,000. Okay. Or 10 to the minus 3 amperes. Right. Let's do the next set of readings. What do I have to do next, guys, according to the instructions? Come on. I have to add another bulb in. So I add another bulb in series, correct? I just want to check that the bulb is working. Okay. So I'm going to add another bulb in series. And then what? I'm going to check the ammeter reading again, hey? Guys? Yes? So I need a second ammeter reading. And the second ammeter reading is 110. 110 milliamperes.
Put the lights off.
Second ammeter reading is 110 milliamperes. Right. For the potential difference, what am I doing? Where am I attaching this? I need a reading over the one and the reading over the other. Yes? Are you ready? Reading. And the second reading is 2 away from 1,2. 2 away from 1,2. On this side. Makes sense? So write down that reading, please. Sorry? V1. This is V1's reading. And it's 2 away from 1,2. So the reading lies over here. So that's 0,6, alright? That's 1,2. Okay. Do you understand how to do the calculation, grade 10s? Can somebody talk me through it? Massimo, go for it.
You need to say it's 0.6
Yeah.
plus 8
Yes.
times 0.06.
Nice. So we're going to say 0,6 plus 8 times 0,06. Okay, to get your second reading for that voltmeter. Alright, the next one Voltmeter reading number 2. And it's 4 away from 1,2. So it's 4 away from 1,2. Can you calculate your new reading? Be 1,2 plus 4 times 0,06. Are you okay with that, grade 10s? That's your next reading. Okay. What's the next step? What's the next part of the experiment, guys? I'm going to add another bulb. Agreed. So, I'm just going to check that the bulb is working again. Okay, good to go. Okay, I have that connected. I have that connected, and there's the tiniest glow happening. All right, there's a teeny tiny glow happening. Okay. All right. Any idea why there's just a teeny tiny glow happening? Rachel? That's right. Every time that I add another bulb into a series circuit, the current becomes less because the resistance becomes more. Okay. All right, guys. Now that I have this, I am going to take some voltmeter readings. Are you ready for it? Yes. Okay, so, come on, voltmeter. Okay, first voltmeter is going to be 0.6 plus 3 divisions. Write that down, 0.6 plus 3 divisions. 0.6, 1, 2, 3. The next reading is 0.6 plus 3 divisions. That makes sense. 1, 2, 3. Those two bulbs are very similar. And then the last one is going to be 1.2 plus 2 divisions. Put those readings down for me, please. Very much so. Can you understand?